But there are means of counteracting the elements. The risk of shipwreck can be minimized by charting the sea lanes. This film tells about an extensive project by the Saudi Arabian Ports Authority, which has commissioned the Georeda company to completely rechart the Red Sea coast. This far-reaching contract includes geodetic satellite measurements, aerial photography, bathymetric survey, side scanning, wire dragging, and other assignments. Using satellite measuring, the geodetic survey monuments are placed at 10-kilometer intervals. Six satellites circle the Earth, transmitting signals to receivers that transform the data with extreme accuracy into coordinates of the receiver antenna. A new planning sketch has been made from satellite photographs of the Red Sea. Subsequently, aerial photography has given precise information on the position and configuration of the shoreline, islands and reefs. This phase precedes the actual sea survey. Photographs are processed in the aerial photo laboratory. The area to be measured by the survey launches equals 270,000 linear kilometers. The work is being done along a 2,000-kilometer shoreline, extending from the Jordanian border in the north all the way down to the North Yemen border in the south. Modern sea surveying uses computer and satellite technology and deep-sea measurement. In practice, the sea survey is performed by up to 8 survey launches, working from a mothership called Maram. Daily schedules are planned on board the Maram. While operating far out at sea, the survey launches do their position finding by Suledis radio beacons installed on the geodetic survey monuments. The automatic beacons transmit unmanned. They require only occasional service, which includes cleaning dust and the droppings of birds from the solar panels producing the electric power. It's been necessary to build the beacons far out at sea. The surroundings are difficult from the maintenance standpoint. Planning the survey areas continues from day to day. And the surveyor on the mothership receives his instructions before he sets out to sea. To facilitate a daily check of instruments, so-called calibration points are built on the reefs. In the morning of the working day, the surveyor obtains the right coordinates. Calibration points are built from time to time as the work advances. If required, the surveyor corrects the setting of the instruments to maintain the accuracy needed for the sea survey. The survey work commences by feeding in and starting up the program. The surveyor works out a detailed survey program for the computer and checks the Suledis ranges. The survey launch is kept to the pre-planned route with the aid of navigator's numeral display. A track plotter traces the route travelled by the launch to the survey area. The echo sounder is activated. In addition to the data on the magnetic tape, graph paper is used to register the depth. If required, contact with the office on board the mothership Maram can be established by radio telephone. Specially trained staff maintain the survey instruments and computers. Awkward operating conditions entail stringent standards for instrument maintenance. A separate personnel is needed to look after the launch engines and perform other tasks to maintain the seagoing vessels. Drinking and household water is evaporated from seawater on board the ship. Between 7 and 8 cubic meters of fresh water is produced every day and night, and it really tastes like water. The nearest inhabitants, local fishermen, are made welcome to avail themselves of the water supply of the ship. In these surroundings, fresh water is scarce. It's just as warm outside as in the kitchen, where the cook prepares delicious helpings for the hungry seafarers several times a day. Lunch hour is a much appreciated break from the arduous work. There are more hungry ones waiting their turn outside. The working day is nearing its end, and the survey launches are approaching the mothership with data gathered in the survey area. The area is swept by radar mounted on the roof of the launch. If rough weather is expected during the night, the survey launches are tied to each other by a stout rope that is further secured to the stern of the Maram. Otherwise, the launches are kept beside the mothership. The results are scrutinized daily as the survey vessels gather alongside the ship after work. Then the magnetic tapes and the reports are transferred to an interim storage unit to await data processing in the computer center on board the mothership. Survey information is transferred from the magnetic tape to the disk memory device, where it's available for the various phases of data processing. Corrections to allow for the tide are deduced from the data. Survey information is preserved on the memory disks during the entire data processing phase. The information is checked and compared using echograms. Disturbances due to fish and other factors are eliminated. The area surveyed is marked on a map to follow up the progress of the survey work. Then one can monitor what sort of progress is being made in the surveying work. The computer-guided plotter automatically drafts the work charts on paper with great speed and accuracy. The depth figures supplied by the survey launches will be transcribed onto the work charts after data processing. The final data files are stored on magnetic tapes to be used subsequently in the chart printing plant. The survey launches that operate farthest out at sea often return to base after darkness has enveloped the mothership. As the work continues from week to week and month to month, the ship has to be moved occasionally so that it will not be too far from the survey areas. Many different methods are used in this survey work so as to eliminate all possible errors. One of the instruments used is so-called side-scan sonar. This measures the area between various survey lines to reveal possible reefs and dangerous obstacles that have not yet been detected. Towed by a special cable, the towfish transmits sound impulses from either side. Reflected back from possible undetected objects under the water, these are registered on graph paper. The ultimate safety of the waterway is guaranteed by a wire dragging operation. Dragged underwater at a pre-selected depth between two vessels, the wire reveals every obstacle appearing above this depth that has not been spotted by the electronic instruments. Anything unusual and undetected could jeopardize safe navigation. The depth desired is determined by upright setting techniques. By using buoys, one can discover where obstacles are located. The object is located for a more thorough inspection by an electronic position finder. Blasting or dredging will be done later. One part of the sea survey involves oceanography. This permits the measurement of certain properties of the sea. These include conductivity, indicating salinity, and the character of the current. The buoys already marked on the charts are pinpointed. Here, the divers are recovering a current meter from a depth of 29 meters. The magnetic tapes that store information from these devices are replaced monthly. A current meter is used at various depths. It measures the direction and speed of the current, temperature of the water, and conductivity to ascertain the degree of salinity. The water level is continually registered on graph paper for a subsequent analysis of the tides and tidal correction of the survey results. The character of the tide is deduced by harmonic analysis. Wave riders transmit signals to the data receivers located along the coast. Data from the automatic meteorological station are registered for future analysis and forecasting. But life on board is not exclusively work. Everybody has a day off once a week, and there are no spare time problems. Some of the personnel are keen on diving, and the surroundings are ideal because of the warmth of air and water. A new, colourful and wonderful world opens up below the surface. Some denizens of the deep may be dangerous and best avoided. Windsurfing is another popular pastime. The native population is used to the sea. Side by side with their modern technology, the Arabs maintain their old culture and traditions and still build sturdy wooden ships. The radio telephone on the mothership is in daily use for direct contact with Finland or Georeda's offices in Jeddah.
Georeda office, Georeda office.
It's in Jeddah that the chart-making process continues on dry land. With the stereo plotter, the reefs are drafted from the aerial photos to the required scale. To obtain the correct results, you need many years of experience and a steady hand. At every stage, the company's directors keenly monitor how the work is advancing. Men from many nations work together. Their aim is the best possible result. The old nautical charts are corrected using data from the latest measurements. When all the data have been compiled, a written report is drawn up. It's scrutinized by a Finnish expert before being presented to inspectors appointed in an official capacity by the Saudi Arabian Ports Authority. Once they have given their green light, the work can proceed to the printing stage. The depth data and coordinates recorded by the mothership Maram